Hello viewer, welcome. In this video, I am going to show you how to build and Dockerize a Spring Boot application and Cassandra NoSQL database using Docker. You will learn about how to run them as microservices in separate containers using Docker Compose. Let me tell you why I needed to make this video. There was a use case in one of my previous projects where I needed to run Spring Boot and Cassandra database in separate containers using Docker Compose. Nowhere I found this solution on GitHub or in any YouTube video. There are some videos, but they have not given the solution as I need. That is, running both applications in separate Docker containers as microservices. I saw some videos where they have given how to integrate both the Spring Boot application and Cassandra NoSQL database, but I saw either one is Dockerized and another is not Dockerized. That's the reason I wanted to make this video, since it took me a lot of time to find a solution and make it work. So if you want to know how to integrate both Spring Boot and Cassandra databases and how to run them as a microservices in separate containers, stay tuned until the end of this video. Let's get started. Before getting into the session, let us know what is the agenda. We are going to have a brief introduction about Spring Boot, Cassandra, and Docker Compose. And finally, we look at how to containerize Spring Boot and Cassandra, and we'll run both Spring Boot application and Cassandra database using Docker Compose. And also we'll have a small test. Basically, we are building REST API using Spring Boot framework. By calling REST API, we can insert the data on Cassandra. What is Spring Boot? Spring Boot is an open source micro framework to build microservices or REST APIs. And it enables Java developers to get started with auto-configurable production-grade applications quickly, without losing time on preparing and configuring applications. Provides ready-made templates to connect various systems like databases, APIs, and LDAP systems, and many more, without much efforts and configurations. What is Cassandra? Cassandra is a NoSQL database, and it's open source database system that can handle huge amount of data spread across multiple commodity servers. Easily scalable to meet in sudden increase in demand by deploying multi-node Cassandra clusters, and highly available without single point of failure. Cassandra is distributed NoSQL database, and it is column-oriented database, and it is compliant with ACID properties, highly consistent and fault-tolerant. Data model is based on Google Big Table. What is Docker Compose? Docker Compose is a tool designed to run multiple containerized applications. Basically, those applications are containerized using Docker engine. As per Docker, one application per container. It is difficult to create and maintain multiple containers, but Docker Compose solves this problem by defining containers in a single YAML file by linking them together and run at once. Let's get started with demo. To build any Spring Boot application, the starting point can be a Spring Initializer UI that looks like this. On Spring Initializer UI, you can choose which version of Spring Boot you want to use or which version of Java you want to use, and you can choose even the build tool as well, Maven or Maven project or Gradle project, and even you can build Spring Boot application using Kotlin or Groovy language as well. More importantly, you can choose the required dependencies. You can search on it here on Spring Initializer so that you can have the proper version of the required dependencies on your pom.xml, and even you can name your application or artifact name and group name, all those stuff, and you can download this project as a jar, or you want to build your application as a jar or a var, you can choose that here. So once you choose all your required dependencies and build tool and versions of your Spring Boot and Java, just you need to click on generate button so that it will download application as a zip format. You have to unzip that, and you can import the project in your favorite IDE like IntelliJ or Eclipse or maybe VS Code, as you like. So for our applications, we need three dependencies that is showing on here. Spring Web. Using Spring Web dependency, you can build RESTful APIs, and Lombok. Lombok basically is to avoid the boilerplate code. For example, if you are building any application, you may write entity classes or pojo classes. So in that class, you may write so many getters and setter methods and converting string, all those stuff. So if you have the Lombok dependency in your Spring Boot project, by adding some annotations, you don't need to write any getter setter methods. And also the final and important dependency, that is a Spring Data for Cassandra. So this library contains all the configurations and how to connect the database from Spring Boot application to Cassandra and everything. You don't need to write any code for this. So it simplifies a lot of things. So it will reduce the development of your application and it will increase the productivity of the developer. Spring Boot application, this is the main class, and we need an entity class, and also we need Cassandra repository class to connect the Cassandra database. And also we need Cassandra cluster config class, which will take care of the configurations of Cassandra cluster. And we need a controller where we define a REST API endpoints. And we need a Docker file for our Spring Boot applications. And we need Docker Compose file where we define the services that are Spring Boot application service and Cassandra service. Once we define all these services in Docker Compose file, we are ready to run the both applications using a single command. Let's start building the project using Spring Initializer. I'm going to build as a Maven project and language is Java. I'm going to choose the Spring Boot version 2.1.16. The group name I'm going to give it as Techtter Cassandra Spring. Instead of Spring, let me make it as a boot, Spring Boot Cassandra integration. Description can be Spring Boot. And we need 3 dependencies, as I said. We are done with choosing all the requirements on Spring Initializer. I'm going to use Java 8 version and it's going to be a jar application. So click on the generate button. So it downloads as a zip file. So we need to unzip this file and we need to import this project into our IntelliJ IDE. I just unzipped the downloaded zip file. Now we have to import the project. Yes, this is the project. Open. It's a Maven project. So it's resolving the dependencies. So it will take some time to show the actual structure of our project. Let's wait for that. You see that the basic structure of our project, everything is here, and we need to choose the right Java version for our project. So already Java 1.8, that's fine. And import changes. Once you refresh, all the errors will go off and you can see the proper structure. You can see the POM file with all dependencies that we have defined in a Spring Initializer user interface. The Lombok dependency and Cassandra dependency. For this and all unit test dependencies will be added by default. All those stuff, default things. Actually, these and all not required for us, but okay, let us see. Now we have to define the application.properties file. Of course, we don't need these things. Yes, we have the basic structure for our application. Now let us create another folder which is going to be a controller. First we create all the required folders, then we go for each and every class that we need to create. We need a model package and we need a config package. I think that is enough, or maybe we can have repo package as well for our repository class. That's it. First we create the entity class for our application that is going to be student. So it's going to have private fields, that is ID, and another private field that is string, that is name, student name. So it's going to be a table. We have to refer this particular entity class to the table in the Cassandra database. Put the table, and also we need data. This is from Lombok. As I said, Lombok avoids a lot of boilerplate code. Just you need to define the required fields in this class. You don't need to write any getter setter methods or any string conversion methods. And also we need no args constructor as well, and also all args constructor, and getter annotation and setter annotation, and id is going to be a primary key for our table. That's it. You don't need to write any getter setter methods once you have the Lombok dependency in your project. Now we create repository class, name it as student repository, and it's not a class, it's an interface. This extends Cassandra repository, and so generics will be student, and primary key is going to be integer, that is id. Now let us create a student controller class. It's going to be a REST controller, and it is accepting the request at this endpoint called starting root endpoint for our REST API. It's going to be just API, and we need a student repository in this controller so that we can access the database from here, and this needs to be auto void. Let us create a first method that is going to be add student method, which can have the endpoint as students, and it is going to, whenever you call specific REST endpoint, it is going to insert the data into Cassandra database. So let's define this method public student. Once the student data is successfully inserted into the database, and it will return the inserted student information back to the client. So that is the student the return. So it returns the student data. Method name will be add student. So it will have the request, have the request body that contains student information. So we need a student repository to get the access to Cassandra database. So we are going to save the student information that is received via the request. So it's going to be post mapping. The endpoint is going to be /student, and we need to return the student once it is successfully inserted into database. This is for create. We are going to core operations using this REST API, that is CRUD operations: create, read, update, and delete. So this specific method is to create the data into Cassandra database, and the next one could be reading. So it's going to be get mapping, and the REST endpoint going to be students. Sorry, this method returns the list of students actually, so we have to return the list of students. Get students. It doesn't have anybody, just we are trying to get the information from the database, that is the student information. So it is going to return list of students. So return student repository find out. So once you call this particular method, it will return all the information, that is all the rows in the table of student in Cassandra database. So get mapping is done, and we are going to have another method that is to update the existing data in the Cassandra database, the existing rows in student table. So it's going to return response entity, that is student information, the method name is going to be update student. Obviously it will have the body, that is request body. You can name it as student details, and also we are going to update the existing row in a table. So we need to retrieve that particular row first, then we need to update on that particular row. So for that, when you are sending the request to this particular REST endpoint, you should send the ID of the student. So that ID will be the path variable. So this is integer. We'll come to that later. Let us retrieve the student information from, so we need to call find by ID, and we need to pass the student ID that is received as part of the request in the path variable. If it doesn't found, we need to throw some exception. We need to handle the exception here, that is resource not found exception. This is a custom exception. We are going to define a class for this specific exception. Student doesn't found. If you want to return the student ID, you can return. So for this specific student ID, doesn't found. So once we got the student information, let's close here. So student set name, which name we had to set, that's we received via student details in the request get name. So we are going to change the name in the existing row in a table. That is a student repository. So we have updated it in the session, current session, and we need to send back to the Cassandra database. That we can do like this. Save. Updated student. No, sorry, should be student here. So once it is done, just return the updated student information back to the client. Let us create this class along with this extends runtime exception. We create the constructor for this. That's it, and we need to create one more method to delete. I forgot to put, this is a post mapping, put mapping, not post. Going to be students, and we get the ID. So we need to have one more method for deleting the row in a table, that is going to be responsive. So public response entity. It doesn't want to return anything, so that is going to be void. So as part of this, we'll receive the request body. Actually, we can copy completely. So student repository delete. We don't want to return anything. Of course, we need to return the empty list at least. That is return response entity, saying it is okay, deleted. So that client knows that successfully the specific row was deleted. That is it, and the controller class is ready. So we have created methods for creating a row. This is for, so we have defined the methods for all the 4 operations: create, read, update, and delete. Now the controller class is ready, and model class is ready, and repository class is ready, and we need to define some config classes. Actually, these config classes are useful to connect with the Cassandra database if Cassandra database is not up and running. So how to handle that exception without destroying the Spring Boot application container. So this whole logic has been written in the configuration class that I'm going to add it now. I'm not going to do it step by step because I got it from the internet. Let me add those two classes now. Yeah, I added these two configuration classes in our project. The first one is cluster config class, which will contain all the required properties to be set on Spring Boot application to connect with the Cassandra database. The properties we are going to define in our application properties file in few moments. And also we have another class which will take care of retrying the connection with Cassandra database, because when we run both application using Docker Compose, Cassandra database may take time to completely to come into running status. So in between, if the Spring application is trying to connect with Cassandra database, it cannot be connected. In that case, we need a retry functionality to connect with Cassandra database. So that kind of logic has been written here. So these are the two ones, and we are going to add some properties in our application.properties file that are, we already have two properties here. It's going to be key space, my key space. Just I'll want to give as my key space. Contract file is going to be Cassandra, and also we need to add one more property, that is this property takes care of if there is no table or schema inside the Cassandra database. So obviously Spring Boot take care of to create the key space and required table for us if it is not available in the database. Let us see how it works. We have done with all the required properties and also required classes: configuration class, controller class, model class, and main Spring Boot application class. That's it. And we need a Docker file for our Spring Boot application. We need to Dockerize this Spring Boot application. So for that, we need to create a Docker file in this directory, that is going to be a Docker file. This Docker file contains from OpenJDK. We are going to get it all fine. This is a very lightweight JDK image, but we can get it from Docker Hub, and we need to have org. And whatever the jar file that we build using Maven, that will be stored under target folder, and we rename it into app.jar. To run the Spring Boot application, we need to use entry point. That's it. So using this Docker file, we are ready to Dockerize our Spring Boot application. And we need Docker Compose. In Docker Compose file, we are going to define services. One service will be a Spring Boot application Docker image. Another service will be Cassandra image service, Cassandra database service. So to Dockerize the Cassandra database, we can define how to Dockerize it in the Docker Compose file itself. It's a already built application, right? So we don't need to build it. So we need to just pull the image from Docker Hub for Cassandra, and we can define that particular service in Docker Compose, and we are ready to run both the applications. And one more thing we want to see, I don't want to do any test, so we are just disabling the test so that we can compile this application without any issues. There is some error. Comment all test annotations so that no need to deal with this stuff. Yes, build is success. And we want to rename the final jar into a different name. That we can do it here. Final name, I'm going to rename it as Spring Boot Cassandra INT. I think this is fine. Let us test it. How the name is going to be, whether it is working. We should see the new name here instead of having 001 snapshot. The image name should be without this, but yes, we got it. Now define the Docker Compose file. So I just copied the content of the Docker Compose YAML file. So we have the version as a 3 in the first line and services. So I named it as a Spring Boot app. That is going to be our container name, and ports. So we are going to have the Tomcat REST endpoint that can be accessed on 8080 port and is assigned to the host machines 8080. the build and context. So we are going to run this application under this context. So we have this Apache Cassandra, Spring Boot Cassandra. No, we need to change this because we named it as Spring Boot Cassandra integer. So that's it. And the Cassandra database. So this will take care of pulling the Cassandra image from Docker Hub, and the name will be the Docker. The name of image will be the Cassandra, and if you want to pull the specific version like 3.14 something like, otherwise it will always pulls the latest image of Cassandra. And I'm going to name it as container name as Cassandra DB. The default port will be 9042. So that's it. So Docker Compose file is ready. So using this Docker Compose file, we can run both applications in separate container as a microservice. So with one simple command, I'm going to run both applications using Docker Compose. Let's run this. Let us see whether we face any issues. Docker Compose up. I think there is no any issue. It's going to start. Cassandra is up and running, I think. Now the Spring Boot application trying to connect. Yes, it's connected. It started. Now we can test with Postman. I have the Postman already installed in my machine. First run the get. Yes, it returns the empty result, and we are going to insert some data using post method. So body is going to be like this, and I'm going to insert name as Shraddha and ID is 1 using post method. Yes, inserted, and one more. Yes, inserted. Let me insert one more. Yes, and now I inserted 3 rows. Let me retrieve those information. Yes, so whatever the data that we tried to insert using REST API, those rows were successfully inserted into Cassandra NoSQL database. That's the reason we are retrieving this information. And even we can update by calling the put method. Let's call to and give the method ID and update name as something John. So just we are trying to update the name. Let us see what will happen. Yes, the name has been changed. Let's retrieve the information. The second row has been changed with the new name John. That's it, guys. I think now you have learned how to Dockerize the Spring Boot application and Cassandra NoSQL database, and how to run them using Docker Compose as microservices in separate containers. I hope this video is useful for you and you have learned something new from this video. Before wrapping up the video, let us see what we have learned. So you have got the brief information about what is Spring Boot and what is Cassandra and Docker Compose. And finally, you have seen how to Dockerize the Spring Boot application and how to build REST API and using Spring Boot framework, and how to Dockerize Cassandra database as well. And we have run the both Spring Boot application and Cassandra NoSQL database in separate containers as microservices. And finally, we tested the REST API that we have built using Spring Boot, and we have inserted the data and updated the data and deleted the data. So we have done all CRUD operations using our Spring Boot application. And that's it, guys. And if you have, I hope this video is useful for you and you have learned something new from this video. That's it, guys. If you like this video, like it and press the bell icon to get the regular updates. And if you are new here and you are not subscribed to channel, subscribe it.